Hi, my name is William Fielder, and I have developed a precision irrigation system that I call 3D Precision Irrigation. In this video, my cat and I will first describe and then demonstrate the components and processes that comprise 3D Precision Irrigation. First, we have a container of dry soil and another containing wet soil. There are two moisture sensors. One is located at the base of and adjacent to the plant's root ball, and the other halfway to the surface. The data collected from these sensors is what determines the state of the controller and why I call this 3D precision irrigation. When both sensors report that the soil surrounding them is sufficiently dry, the controller will begin an irrigation cycle. The controller operates a solenoid valve that it connects to an array of drip emitters and an elevated water storage tank. The irrigation controller that I am using for this demonstration is the one that I used to develop the controller's algorithm. It turns out that it's also the best one to demonstrate it. This model was developed for plants, such as succulents, that require the soil to remain dry for a period of time before irrigation begins. This period of time is represented by the red LED. The dry period is normally measured in days, but for development in today's demonstration, it is set to only 5 seconds. Should a sufficient amount of moisture be detected at either sensor during the dry period countdown, due to rain or a broken pipe, then the countdown is canceled. The red LED will go out, and one or both LEDs related to the moisture sensors will light. The controller will then continue to monitor the state of the sensors until both report that the moisture content of the soil surrounding them is sufficiently dry to initiate a new irrigation cycle. During an uninterrupted irrigation cycle, once the dry period countdown expires, the red LED will go out and irrigation will begin. This state is represented by the blue LED. When a sufficient amount of moisture reaches the upper sensor, the yellow LED will light and irrigation will continue until a sufficient amount of moisture is detected at the bottom sensor, at which time the solenoid valve will close, the blue LED will go out, and the green LED representing the lower sensor will light. Unlike other irrigation controllers, this system is entirely data-driven. It doesn't require any timers except for the dry period countdown. It doesn't require a rain gauge or any internet-connected weather service to guess when it's time to begin an irrigation cycle. That completes my introduction. Now I will first demonstrate a complete, uninterrupted irrigation cycle, and then I will interrupt the dry period countdown, first with the upper moisture sensor, and then the lower. I will then complete the demonstration with another complete, uninterrupted irrigation cycle. So now I'm turning on the controller. The dry period countdown begins. The valve is open, the blue LED comes on, and water is flowing through the emitters. I will now move the upper sensor over to the moist soil. The yellow LED comes on and water continues to flow through the emitters. Once I move the lower sensor over, as I said, the valve will shut, the blue LED will go out, the green LED will come on representing a sufficient amount of moisture in the soil surrounding the lower sensor. So here we go. Just that fast. And that's what makes this system so precise. Okay, next I'm going to show you what happens when we interrupt the dry period countdown. First with the upper sensor and then the lower. There it is. It's interrupted before the 5 seconds expired. The blue LED didn't come on, meaning that the solenoid didn't open, and there is no water flowing through the emitters. It will stay in this state until the soil surrounding the upper sensor goes dry, and no moisture is introduced to the lower sensor. So here we go. This time we'll use the lower sensor. And again, the solenoid valve didn't open, the blue LED didn't come on, and there is nothing coming through the emitters. Okay, I'll conclude this demonstration with a complete cycle. There we have water flowing through the system. Moisture is detected at the upper sensor and then the lower. And that concludes a complete irrigation cycle and this demonstration. Thank you for watching.